All right, everyone, buckle up because we're diving deep into the atom. But forget those boring diagrams. We're talking vibrant colors, glowing signs, even those breathtaking sunsets.
Yeah, those everyday wonders we often take for granted.
Exactly. And it all boils down to some seriously cool physics happening at the tiniest level.
We're talking about electron transitions.
Electron what now?
Okay, so you know how atoms have those electrons whizzing around a nucleus?
Yeah, like a super mini solar system.
Right. Now imagine those electrons aren't just randomly zipping about. They're more like performers on a stage, but they can only stand on specific platforms.
Platforms, what do you mean?
Each platform represents a different energy level. The higher the platform, the more energy the electron has.
So it's like climbing a ladder, higher rungs, more energy.
Perfect analogy. Now, each electron has its favorite platform, called its ground state, its comfy home base. It's the lowest energy level, and electrons would love to hang out there all day.
But they don't always get to chill, right? I mean, our source mentioned this guy, Niels Bohr.
Ah, yes, Bohr. He was onto something. His model of the atom really helps us visualize these energy levels.
Right, like those platforms aren't just random, they're specific distances from the nucleus.
Exactly. Just like planets have their orbits, electrons have their designated energy levels.
And just like it takes energy to blast a rocket further from Earth, it takes energy to bump an electron to a higher platform.
Now you're getting it. Think of it like this. An electron absorbs energy, could be from light, heat, even electricity, and boom, it suddenly got the energy to jump up to a higher energy level. We call that an excited state.
So it's like giving that electron performer a jolt of energy, and they're suddenly tap dancing on a higher platform.
Love it. But here's the thing. Just like we can't stay hyped up forever, that electron can't stay excited forever. It wants to get back to its chill ground state.
And that's when things get really interesting, right? Because how does an electron going back to a lower energy level create, like, the colors in a neon sign?
Okay, get this. When that electron drops back down to a lower platform, it releases the extra energy it was holding on to. And here's the kicker. It releases that energy as a photon,
A photon.
a tiny packet of light. Get this, the color of that light. It depends entirely on how far the electron fell. Each jump, each transition releases a very specific amount of energy and therefore a very specific color.
Hold on. So you're telling me each color we see, like in a neon sign, is the result of electrons jumping down these energy ladders, releasing different photons?
Bingo. Think about those bright red neon signs.
Okay, yeah.
That's the specific color emitted by excited neon atoms when their electrons make a particular jump back down to a lower energy level.
Yeah.
They're designed that way.
Wow. So they're basically controlling which jumps the electrons are making.
Exactly. They pump energy into the neon gas, exciting the electrons, and then as those electrons naturally fall back down to their ground state, bam, red light.
That is so cool. And this isn't just neon, right? Our source mentioned something about this being how we can identify what stars are made of.
Exactly. Every element, from the hydrogen in the sun to the oxygen we breathe, has a unique set of energy levels, its own custom-built stage with platforms at very specific heights.
Okay, I'm following.
So when you excite an atom, the electrons jump between those unique levels, and when they fall back down, they emit those super specific photons of light,
Creating those unique colors.
creating a unique fingerprint of light. We call this a line spectrum, and it's how astronomers can analyze the light from a distant star and say, aha, that star has hydrogen and helium, and you get the
Yeah.
idea.
It's like their own cosmic barcode scanner. That's incredible. But there's one part that still kind of blows my mind, this quantum jump business. Our source mentioned that these jumps, these transitions, they don't happen gradually.
Yeah, it's not like an electron slowly sliding down a rainbow from one level to another.
Right. Our source is pretty clear these jumps happen instantly. Like, poof, gone from one platform, then boom, appears on another. How is that even possible?
It's one of the weird and wonderful things about the quantum world. Things don't always follow our everyday logic.
So those electrons are basically breaking all the rules.
Well, not quite. They're following a different set of rules. The rules of quantum mechanics, which are definitely a bit mind-bending compared to the physics of our everyday world, but that's a whole other deep dive.
All right, so we've got these electrons hopping between energy levels, emitting light like tiny disco balls, creating everything from neon signs to starlight. It's amazing how something so small can have such a big impact. And to think, it all comes down to that electron's desire to get back to its chill, ground state self.
Exactly. That drive towards stability, towards the lowest energy state, that's what drives so much of chemistry and, well, existence. It's the underlying principle that dictates how atoms interact, how they form the molecules that make up, well, us.
It's pretty humbling when you think about it. Those mesmerizing colors we see all around us. Just a glimpse into the secret life of atoms, those tiny performers putting on a spectacular quantum show. Who knew physics could be so colorful?
Right, and this is just the beginning. Imagine what other mysteries are still hidden within these seemingly simple atoms. The journey into the quantum world is just getting started.
And on that note, we'll wrap up this deep dive. Thanks for joining us as we explored the vibrant world of electron transitions. Until next time.
See you in the quantum realm.